Okay, grade 11s. Let's look at the equation of a line. We're talking about the equation of a straight line. And let's first just lay down the foundation. I know you guys know this, but this is important just to look at it again. Okay, so you have the equation. Let's say y equals mx plus c. Sometimes they write that as a q or a c. It really doesn't matter, as long as you're consistent. So in order to get the equation of this straight line, we need the gradient and we need the y-intercept, because that is what c is. It is the y-intercept, and this is the gradient. So if you don't have these two, you cannot get the equation. So let's talk about the gradient first. If the gradient is given, it's easy. You just substitute it into the equation. If the gradient is not given, but you have the inclination, then you can get to the gradient by understanding that the gradient is equal to tan of the inclination angle. Just make sure your calculator is on degrees and not on rad or grad. Okay, so this is the one way we can get to the gradient. The other way we can get to the gradient is if we have two coordinates, A and B, and you can calculate the gradient by using this formula. Okay, so basically that is a summary of how we can get to this gradient of the equation. If you have it, plug it in. If you don't have it, but you've got the inclination, use this formula to get there. But if you have two coordinates, you can get to the gradient by calculating the gradient. Another two things I just need to mention is if we have a horizontal line, the gradient is 0. If we have a vertical line, the gradient is not applicable. Okay, in this case the equation will just be y equals whatever the c value is, and in this case the equation will be x equals whatever the x-intercept is, and that is it. That's basically everything to do with the gradient. Okay, you can see a lot of arrows. Hopefully it makes sense. Now the next thing we need to talk about is the y-intercept. Now again, if it's given, you just substitute it in. But now I'm going to show you 2 or 3 other scenarios that's typically asked where you will need to calculate the y-intercept in, or even the gradient as well. Okay, so let's look at the following scenarios. But wait, before we look at these scenarios, I need to show you this awesome formula. Now, it starts with the definition of the gradient. Okay. I want you to understand that I'm going to multiply on both sides with x2 minus x1. So the one side is y2 minus y1. The other side is m times x2 minus x1. In order to get to the equation of any straight line, we can change this and say y minus y1 equals m times x minus x1. So the y and the x will remain our y and x in our final equation. y1, x1, those are the coordinates of one single point, okay, on the on the actual straight line. So if you have the gradient and the coordinates of one point on the straight line graph, you can get to the actual equation. So I will include this in one of the scenarios when we do the calculations. So the first scenario and the easiest scenario is just, for instance, determine the equation of the line where the gradient is -2 and the y-intercept is 5. So now all we need to do is to substitute. So the gradient is given as -2 and the y-intercept is given as 5. So therefore y equals -2x plus 5. Like I say, I've started with a very easy one. So this is the first one. Similar to this one, let's say they say determine the equation of the straight line where the y-intercept is 3 and it's parallel to the x-axis. So we're looking at a graph that looks like that. This is x, that's y. So it's parallel to the x-axis and its y-intercept is 3. Remember, its gradient is 0. Therefore, we will just say y equals 3. Okay, the next one is, let's say they tell us the y-intercept is 5 and it's parallel to the y-axis. So we are looking at a graph that looks like that. So you've got a vertical line going through 5, it's parallel to the y-axis. So we know that the gradient is not applicable over here. Just like over here the gradient was 0, over here the gradient is not applicable. So now we know this will just be x equals 5. That is the equation of that line. Okay, let's move over to number 4. And this is where that other equation, the second one I showed you, y minus y1 equals m times bracket x minus x1 close bracket. This is where this one comes, is very handy. It comes into play. Okay, so let's say the equation, or the question is determine the equation where the gradient is 3 and the graph is going through the point 1, 4. So this is the information given. So now we just plug and play. Y minus y1 equals m times x minus x1. So y minus, what is the y1? It's 4. What is m? It's 3. What is x1? It's 1. So y equals 3x minus 3 plus 4. Therefore, y equals 3x plus 1. Let's do another one like this. I'll call this then number 5. And I'm specifically choosing negative values so that you can see how it comes into play. So they tell us the gradient is -2 and the coordinate that it goes through is 1 and -4. Okay, so now we start off again with the exact same form. And now we're also just going to substitute. But in this case, you have to be very careful how you substitute. For instance, over here, y minus, and remember, if it's a negative, always put a bracket so that you cannot get confused. When m is -2, x minus and x1 is 1. Okay, so we have y plus 4 equals -2x. The negative times the negative becomes a positive. so it's a plus 2. So therefore y is negative 2x, and the 4 goes across, becomes a negative, so this will become negative 2. Now we're looking at one that looks like this. So they just ask you to calculate the equation of a line which goes through, and then they give you 2 coordinate points. Okay, so let's take an example. Let's say point D, which is 0, -4, and it goes through point A, which is a 2 and a 2. Okay, so first things first, remember we need to get the gradient and the y-intercept, or the gradient and the coordinate. So we have a coordinate, we've got 2. So first things first is we need to get the gradient. So now let's say ya minus yd over xa minus xd. You can swap these two around as long as you have the a's on top of each other and the d's on top of each other. Okay. So now we just substitute a2 ya, which is the y2 normally, is 2 minus, remember your bracket, -4, this is 2 minus, and this is 0. And from here on, 2 minus a negative is a plus, so this becomes 6, and this is a 2, so this is 3. So now we know the gradient is equal to 3. And we have a coordinate we can substitute in. So now we immediately go back to this equation and we substitute. So let's choose D because it's easy. This is 0, so automatically it will make it less complicated. So it would be y minus bracket -4 equals m, which is 3. We calculated it. And based on this, we can then calculate the rest of the final solution. So y plus 4 equals 3x. So y equals 3x minus 4. And this